Hello everyone, this is Ahmed Hamdi and this is Engineering 1005 Descriptive Geometry and Engineering Drawing, and today I'm gonna explain classwork number 3. Okay, so basically we have two drawings, drawing number 1, the one I'm showing right now, and we have another simple drawing or simple object. So I'm gonna explain how to do the projections of this object. Okay, so first of all, let's pick a point and then start to draw the front view. So before we start the front view, we assume that we have, this is the border of our A3 sheet. Okay, and here we are drawing the title block with the dimensions given in the blackboard, and you write your name, ID, and classwork number and everything, all informations. And then you have to organize, before you start the drawing, you have to know where you will draw the front view to avoid any problems or any later problems, like you don't have a space for the side view or the top view. So for this object, actually this is a symmetrical object. Okay, that means if we are drawing the right side view or the left side view, they will be the same, right? So the right side view from this side or the left side view from that side, okay, they will be the same. So we don't have any problems to draw either the right side view or the left side view. For this one, we can draw the right side view. So basically we'll start with the front view, the largest open view of this object, which is 100 here. Okay, I think the camera is now fine. Okay, then we'll start to draw the right side view, and finally we'll draw the top view of this object. So before we start, we have to know that the front view will be somewhere in this area to make a space for the top view and the right side view. Okay, actually the views should be aligned, and we have to keep equal gaps with 30 millimeters between each view. So to control that, we have to draw the miter line with angle 45 degrees here. Okay, it's very simple. So let's start from the scratch. I will start with the front view of this object. So basically this classwork should be done on an A3 paper size, not in AutoCAD. Okay, the camera is blurring. Okay, no problem. So I will pick a point. For example, I will pick that point. Okay, so this point, let's assume it will be somewhere here. I will go up 30 millimeters. Then what will I do? So this line, the length of this line will be 100 minus 60 over 2, because the distance from this point to that point is 100, and the distance from this point to that point is 60. So this is like a symmetrical object, so we have to divide it by 2. So the rest will be the length of this line, which will be 20 millimeters. Okay, so I will go to the right 20 millimeters, then go up 10 millimeters, then go to the left 10 millimeters, and go up 10 millimeters. Okay, let's increase this one a little bit. So basically this value is 10, and that value is 10, and the rest will be 10. Okay, the 30. Okay, okay. The same I can do the other side. Okay, so I will leave 60 millimeters, go 20 to the right, up for 30 millimeters, and then go up from this point 10 millimeters, and then go to the right 10 millimeters, go up 10 millimeters. Then I can close this line. The same for that one, I can close it like this. Then from the midpoint of this 100, I can erase 7.5 and 7.5, okay? Because we have a gap of 15 millimeters. Let's do it with this one here. Okay. After that, I will draw the circles. So the circle is on height of 50 millimeters. So from this point, I can go 30 and then go 50 millimeters, or I can go 80 from the midpoint directly. So let's assume the height of this point is 80 from the beginning, or 50 from that point, okay? And this point will be in the midpoint of this 100. Then I'll start to draw those two circles. The one was 530, this one. And the outer one, the larger one, was 550. Okay? Then I have to draw the tangent lines. Okay? So basically, we know that there is a concept in the applied geometric. If we have a circle and we have an external point and we want to draw a tangent line from this point, first of all, we can match between those two center points, or the center point of the circle and the external point, then bisect, then from the midpoint open our compass to the center point of the circle, and then make a notch on the top side, and then match from this notch to that external point. Okay, we'll do the same on both sides with this circle. So this will be the first external point. Let's assume we do the steps the same here. Okay, and we'll go up until we hit this circle, the same for that one, and then we'll erase this part of the circle. Fine. So now we have the top view, the front view of this object. Actually, we don't have space for the top view, so let's erase it and do it downside a little bit. I will do it again fast. For sure you will do these views not with your hand. It's not a freehand sketch. You will do it with the right scale 1:1 as written here. So you will draw with the exact dimensions given in this drawing. Okay, so first of all, we finished the front view of this part. Sorry, E. Lovely. Okay, then we said that we'll draw the right side view of this component. So let's assume we'll take projection lines with this red color. Okay, then first of all, from the side view we'll see something like a rectangle. This rectangle is 30 times 60. Actually, this is the 30, so we'll go 30 millimeters. Then we'll start from this point. Okay, then we don't have to measure because we took a projection line from that point, so we'll go up 30, then go to the right 60 millimeters, go down 30 and close it. Okay, for sure we'll have something like 2 dash lines. Let's make it, I don't have other colors. So from this point and that point, actually we'll have like 2 dash lines on the side view. So those ones will be dash lines. Fine. This tunnel. Okay. Then if we look at this cylinder, it will be something like a rectangle, and this rectangle has something like a web. This is a web. This is called a web. What is a web? The web definition is like a thin supporting wall, mainly attached to cylindrical objects to support the cylinders. Okay, so if we have a cylinder, that cylinder supported with any base with something called a web. Okay, so the web is a small or a thin supporting wall, mainly attached to cylindrical features. Okay, so if we look at this cylinder, it starts from the first face and end with the back face. So the width or the depth of this cylinder will be 60. Okay, so we'll take projection line from that point. Okay, so now we know the start point of the cylinder, which will be that point. Go up until this point, go 60. We have something like that. Okay, for the hole, we'll make a center line, make a dash line from this point. We'll take a projection, another one here. Okay, so for the web, actually we have a line here. This is a solid line, so this solid line will be solid line right there. The same for the back one. We have another one not shown in the back, because as I told you, this is a symmetrical component. That means that if we have a cutter from the mid plane of this component, so we'll have 2 equal halves. The same if we cut from the mid plane of the side view, we'll have 2 equal halves. That means that we have another web like this one on the back. Okay, so now to complete this view, or this the side view of this object, we have to draw this tangent web. Okay, so basically we have a tangent point right there. Okay, actually this web will be in the midpoint. It's not written the thickness of this web, so let's assume it will be 10 millimeters. The thickness of this web will be 10 millimeters, and it will be in the mid distance. That means that we'll draw 30 millimeters and then take like 5 and 5 from both right and left. Okay, so from the midpoint I will draw 5 millimeters here and 5 millimeters there, and I'll go up until the projection of this point. Okay, so I'll take a projection here from this tangent point. Okay, and then I'll go up and go up here. Okay, so the end point of the web would be something like a small notch, so you will draw something like a random notch with your hand. Okay, so you will end up this web from that point with a notch like this one here. Okay, that means that this notch means that this web is tangent from the side view of the cylinder. Okay, so we have something like that here in the drawing. Okay, so now we are not completing this view. We are missing something very important here. So we have a small mistake line. So some of you will say that we don't have this line, this portion of this line here, because it's like a fused or casted material. So the web is fused inside the cylinder. That means that we don't have something here. Okay, as written here or as drawing there, we don't have any lines here. And actually the cylinder will stop at this face of the web and then start with the back side of this web. That means that we don't have any lines here, and actually we don't draw like dash lines here. Okay, so now we end the side view, right side view of this object. Okay, so to draw the top view, we'll go up from that point until we hit this virtual point, and then draw 45 line like this one, and then start to draw the top view. So first of all, the top view basically will be something very simple. So let's draw it randomly here and then draw it with those projection lines. So we'll have something like a cylinder, and inside this cylinder we have a hole, right? And then we have a tangent line from the right with no lines right there. The same from the other side here. We don't have anything here. And then we have the base. Right? And then we have like those points. From those points we have different edges, so we'll have like multiple dash lines here, one here, one there, the same here and there. Those two dash lines are representing those 2 points. Okay, the same for the other side here. And finally we'll have this whip. Okay, so this small whip will be dash line under the cylinder. So if we draw it with a larger scale, let's put this here. So let's do it with larger scale. So this is the cylinder and the hole inside the cylinder, and then we'll have a web, the side web, okay, and we have another web will be dashed here. It will continue on the back. So what will be there in this area? So those 4 webs will be connected like a cross sign. So we have 1, 2, 3, and the 4th one on the back. We have 4 webs. Okay, those 4 webs will look like that. They should be connected like that. Okay, so some portion of those 2 webs will be solid, and the rest will be dash. So let's make it with another color. So the ones I will make with blue one will be the solid lines of the web. Then we'll have something like that. Okay, so this is the connection of the 4 webs under this cylinder. As I told you before, we have 1 web, 2, 3, and the 4th on the back, the opposite of this one, the symmetrical web of this one on the back. Okay, we have 4 webs. So the ones in the red will be dash webs, and this blue one will be the solid ones. Okay, So as I told you before, if we took a projection lines of this web, of this the top view of this part, it will be something like that. This will be the base. Inside the base we have the tunnel, the projection of this point and that point will be those two dashed lines, the same from the other side. Okay, then we'll have the cylinder in the middle, so we'll take a projection from the quadrant points of this cylinder, make a center line, make a hole, then make the webs like this one. Okay, so those ones will be exactly here. The ones in the red color are the dashed lines, and the blue ones will be the solid lines. Again, this web from that point, actually it continued under the cylinder. The same from this point, we have another line right there. That means that we'll see the web under the cylinder. We'll see like the change of planes. So we'll have edge here and edge right there. Okay? The same here. So this will be the part or the portion of the solid line of this web. And this blue one will be that one. Okay? And that one, this arc, okay, will be this portion. This arc will be this portion of the dashed line, because this arc will be under the cylinder. Okay, so this is why this one will be in dashed lines. Okay, so this is the first drawing. It will be something like that. Okay, so this will be the front view, and that will be the side view. Okay, and this will be the top view, and we'll put this drawing inside that one. Okay, so let's move to the second drawing. So this is the second drawing. I tried to make it with a clearer dimension. Okay, so which will be the front view of this object? Actually, as we told you before, the largest open view will be the front view. So that means that this will be the front view, because this is the largest view. So this view is actually 100, because we have 60 from those two center lines, and then we have an arc here with R20 and another same one here. So 20, 20, 40, and 60, say, so we have 100. And for the width, actually we have 40 here and 30. So this is 70, and then 20 millimeters from this center point to that peak point. So we have 90. So that means that this will be the largest view, the large open view, this one. Okay, so this will be the front view of our object. So if we'll draw this view on the separate sheet, we'll draw it on the right side, because we'll draw, actually this one is a symmetrical object. That means that we can draw either the right side view or the left side view. But actually we have the open one is the left side view, so we can proceed with the left side view of this object. Okay, so for the front view, actually this slot shape would be something like a rectangle. So let's do it here. Okay, so this rectangle, as we said before, it will be 100 times 10. So this is the 10, the thickness. Okay, and then after distance of 20 millimeters, I'll draw a center line here, the same here. Okay, then Around this center line, I'll draw the dashed lines of the holes. So the holes will be 10 and 10 because the hole is phi 20 millimeters. So I'll go 10 to the right and make a dashed line here, and the same for the left, the same for the other side here, dashed line here and there, with 10 millimeters all around the center line. Okay, then from the midpoint of this 100, let's assume this point, okay, I will draw 10 millimeters here and there, okay, because I have this one is 20 millimeters, and I will go up how much? Actually, this value is 40, 50 minus from here. This is 10, as I told you before, right? And it says here the distance from the peak down point is 50 to the center line of this cylinder, and we have 20 millimeters, so the overall distance to the peak will be 70, 50 plus 20, and we have to subtract this 10 millimeters, so we'll go up with 60 millimeters. Okay, so I will go up 60 millimeters. Okay, go to the right, to the left 20 millimeters, and go up from here 60 millimeters. Then I will go down 20 millimeters and make a center line of the hole. Around this center line, I will go up for 10 and draw the hole. The same down here. Okay? So, can you see this part of the line, of this line? Actually, this line, or this part of the line, continued on the back side of this space. That means that it will continue dash line here and there. Okay, so this is the same thickness of 20 millimeters, and this one continued to the ground here, as we can see here. That means that a portion of 10 millimeters of this line will be dash lines right there, behind the base, behind this slot shape. Okay, then we have to draw this pocket, this hole, this rectangular pocket here. So how to draw this one? Let's say that we have a distance here with 15 and 40, and the thickness will be all around 5 millimeters, but actually we couldn't indicate this slight edges, those like inclined edges here. So that means that we have to draw the side view first to indicate the start point and the end point of this pocket shape. Okay, so this pocket continued to down forward. Okay, so this one continued to through all to the down to the ground. Okay, but actually we couldn't indicate this edge and that edge from this view. We have to draw the side view of this object and then make a projections and then make this point pocket. Okay, so let's proceed with the side view first to indicate the dimensions or the start point of this pocket. So we'll go 30 millimeters, then we'll start from here. So basically we'll have something like this. Rounded profile will be a rectangle. This rectangle will be the same height with 10 millimeters and with a width of 20 millimeters from here. Inside this one we have a hole, right? Then let's erase this one. Okay, then we'll go 30 millimeters again, this one here. Okay, then we'll go up how much we don't know. So first we have to draw a circle. From this point, actually we have to go up 50 millimeters, or we can take a projection from here and the extension of this one. So this will be the center point of the cylinder, or those two circles. So I will draw those two circles, one with phi 10, phi 20, and one with phi 40. So this will be the smaller one, and that will be the largest one. Actually, the largest one will not be continued. It will be something like a semicircle, okay? Then we can continue this line until we hit this portion of the circle. And we have to go back to the rule that if we have a circle and we have a line, how to draw a tangent fillet between this line and that circle with 10 millimeters. So we'll go parallel to this line 10 millimeters, and we'll add those two radii. So this is 20 millimeters plus 10. So we'll put the tip of the compass here, and we'll open 30 millimeters, and we'll make a notch here, and then put the tip of the compass here and open 10 millimeters, and then we'll make something like that. So this one will be simple. Okay? Then we can draw a tangent point from this line to that circle. We said the steps before. And now we are missing the pocket, okay? So it says that we have a horizontal dimension from the side view with 15 millimeters. So we'll go from that point 15 millimeters. From this point, we'll go 15 millimeters. Okay, let's assume it should be actually in between. This is 40 and this is 10. Yeah, it should be somewhere. This is, we said 20, 15. So it should be something in between here. Okay. So from this point, I'll go up with the dashed line until I meet or I hit this inclined profile. Then from this point I will go 40 millimeters, and from this point I will go up until I hit this inclined profile. Okay, so this is 40 millimeters, and then I can take a projection from those 2 points, this one and that one. Okay, so those ones will be the start point and the end point of this pocket shape. Okay, so I will go 5 millimeters and draw 10, go up until this line, from here the same, close it, and then from this point I will go down with the dashed line, the same here. So why we draw those 2 dashed lines? Let's explain. Can we see this part of the line? This one here. Let's make it with another pen. This one. Okay. And from this point we have another one here, right? So we have 2 lines. Those 2 lines are hidden and they are continued to the bottom. Okay, so this is why we draw those 2 dashed lines. Okay, I hope you understand it. So from this point we have a vertical line inside and the same another one here. Okay, and they're continued to the ground. Okay, so for the top view, actually we'll draw the miter line from this point with the angle 45 degrees. Then we'll take the projections. So basically it's very simple to draw the top view. So we'll take projections from everything here and there, and then we'll have like red upside here, So basically, after taking the projections, the top view will be something like that. Half circle here, and we have another circle here, the same from the other side. Okay, and this one is closed, and this one is not closed. And for the top view, okay, we have dash line here, and this will be the pocket. So we'll take the pocket from those two projection lines here and there. Okay, so the pocket will be just a rectangle like that one. Okay, and the last point on the top view, actually this point. So from this point we have like a continued edge, right? So we have edge right there. So this edge actually from this point, so it will be something like dash line here. Okay, so after taking the projection, actually it will be around the center line of this. Actually it will be on the center line, I'm sorry. So if we have this edge with the center line, so the center line will be dominant. Okay, so if we have dash line and we have center line aligned on this dash line, so the dominant one will be the center line. So you have to draw the center line. Okay, so actually this edge should be dash line, but actually this edge will be beyond the center line of the circle, so we'll not draw the edge of this part. Okay, and I think we're done with the top view of this object. It's very simple. Actually we don't miss anything, so that's it. Okay, I hope you enjoyed this video, and if you have any questions, just send on the WhatsApp group or send us an email, explain what exactly you're missing in this video, and we'll explain it for you. Thank you, and see you in next videos. Bye bye.